Hey class, today what we're going to look at is compounding interest. So whenever you are, this is going to go back to our exponential, this falls in our exponential unit. Um, and if you notice, this is our compounding interest formula. And if you notice what's inside the parentheses kind of looks like our general form of our exponential equation. So what's inside of this parentheses is going to be our r. The a is the same because that's our initial term. What we raise it to is n times t. So if you notice here, y, that's going to be our final amount of money. A is then going to be the initial amount of money, or this is sometimes called the principal, is the money that we put into the bank account. The r here is going to be our interest rate, and that is as a decimal. So remember, if you're converting an interest rate, so let's say we had like 4%, I need to convert that to a decimal. So percent means per 100. So what I'm going to do is 4 over 100, which ends up being 0.04. So if I have 4%, I would need to put 0.04 into my formula. N, which is in my exponent and my denominator, that's the number of times it's compounded per year. So that means, like all these down here, these are going to be some of the words that you might see. So annually mean that n would be equal to 1. Biannually, n is 2. Quarterly, think of a quarter, there's 4 quarters in a dollar, so quarterly, our n is going to be 4. Monthly would be 12, weekly there's 52 months in a year, and daily would be 365. So whatever the problem says, it's going to fall under one of these, and that's what you're going to put in for n. And then t is just the time in years. So we put all of those things into our formula and then put it all in the calculator, and it should give us out our answer. So let's look at an example. All right, so you've got your uncle. He's going to give you $1,000 on your 12th birthday. And so what we want to do is we're going to put that into a bank account. In that bank account, it's going to earn 3% annual interest. So remember back to what we talked about earlier, 4% was 0.04. 3%, that's the same as 3 over 100, which ends up 0.03. So remember that. This is also compounded. If it doesn't say anything, we're going to assume that it's compounded annually or it's compounded once per year. So that means I would sub in an n equals 1, n for n. So I'm going to write the y equals rule. So remember, I'm plugging in y equals my a, that's my initial term, so that's 1,000. Then I've got my 1 plus my r, which is 0.03, divided by 1, because remember it's compounded once per year. My n, which is 1, times by t. Now in this problem I don't have a t, so I'm just going to leave it as t in my problem. And if I rewrite this, if I do 0.03 divided by 1, that's 0.03, so I'm going to simplify everything. So that's 1,000, 1.03 raised to the t power. That 3 is pretty bad. So if you think about that, this simplifies to this form right here where a is 1,000 and r is 1.03. So we do that, and now remember r is what we multiply by each time to get to the next number. So now we can write our now next. Our start is 1,000, and my now next, I take my now and I'm going to multiply it by 1.03. Alright, so knowing this, either my now next or my rule, I can now complete the table. I can either sub in these values, these are my x's, my number of years, or my t. I can sub those in and get my values, or I can think of using my now next. So I'm going to think of using my now next. I start at 0, and so my balance is going to be 1,000 whenever I'm at 12. So whenever I'm 13, I'm going to do my 1,000. Hit enter, and then we'll multiply by 1.03. So your calculator should look like that. So then we get 1030. And if you set up your calculator like that, remember you can just keep hitting enter, get the next number. So this is 1060.9, 1092.73, 1125.51, 1159.27, and then 1194.05. So that is how we would figure out our table. And now we're going to go into a little bit more in-depth questions. Okay, so now based on all that stuff that we had, if you left the money in an account until your 21st birthday, we want to figure out how much money we would have. So we want to use our formula. So we have this, remember we have y equals 1,000 times 1.03 raised to the t power. Now in this case we know what t is. So remember we started with our 12th birthday. It is now our 21st birthday. So if you take 21 minus 12, you get 9. So we're going to raise it to the 9th power. You could also follow along with your table and just keep on going. So let me pull this one back. So you could keep on going with your table. This is 12, so this will be 13, 14, 15, 16, 17, 18. And then I would need 3 more. And just keep on hitting enter 3 more times. You'll get to your number. Or we can just plug this straight in. So that's what I'm going to do, 1,000, parentheses, 1.03. I'm going to raise that to the 9th power. So it looks like that down there at the bottom. Hit enter, and you see that I get my answer. So I get $1,304.77. So that's how much we would have after 9 years. So now we want to think about it being compounded monthly. Now remember back to the first slide we had, n is going to be 12 here. So now I'm going to redo my formula a little bit. So I've got y equals 1,000 times 1 plus, I still have my same interest rate, but now I'm going to divide it by 12 instead of 1 because it's compounded monthly, which means I also need to multiply my numerator, or my exponent, not numerator, my exponent by 12, and I multiply it by, remember I'm going to my 21st birthday, so my time is 9. And so I don't even need it. You could simplify that if you wanted to, but I'm just going to plug all that stuff into my calculator. So 1,000, parentheses, 1 plus 0.03 divided by 12. And then I'm going to raise that to the 12. Make sure I put parentheses around everything. So after you do that, you get 1,309.52. So if you notice the same time frame, I made, whenever it's compounded monthly, I made about $5 more. So that is going to be key whenever you're in real life, whenever you're trying to decide what bank account you want to figure out how much is being compounded. Because if you get compounded more often, let's say you get compounded daily, you're going to make more money. So the more you get compounded over the same amount of time, you're going to make more money. And that's what you would like to happen. I'm guessing you would want more money. And that's it on compound interest.